morning. We're going to get started today on Module 4. Module 4 concerns itself with solving quadratic equations. Right here, you can see the form of the quadratic equation. ax squared plus bx plus c is equal to 0. A, B, and C here are just constants, so they can be any numbers. And we're going to learn 3 methods of solution for quadratics. We're going to learn how to solve them by factoring, by using completion of the square, and also by using the quadratic formula. In this particular video, we're going to look only at solving quadratics by factoring. And we're going to break this into 3 cases. So case 1 has no middle term here. Okay, so we would just have ax squared plus c is equal to 0. This is called a pure quadratic. So the value of b is 0. And this here is an example. Now the key to solving these by factoring is to make sure that we first have one side of the equation equal to 0. So we start by bringing this constant over to the left-hand side. And that would mean subtracting 66. And we would now have 2x squared minus 72 is equal to 0. And now that we have the right form, we would attempt to factor this. Remember, the first kind of factoring we always look for is common factoring. So these terms are both divisible by 2. So we remove that common factor of 2 first. And now look at this. We have 2 terms. They are separated by a subtraction sign. Look at the exponent here. This is difference of squares factoring. So the factors of x squared minus 36 are x plus 6 and x minus 6. Okay, so we're comparing this with a squared minus b squared right now, with factored form a plus b, a minus b. Okay, and this is something, of course, we just finished doing in the last unit. The difference here now is that with right side equal to 0, we can get our 2 answers for x. And we take those answers by setting each of these factors equal to 0. So x plus 6 is 0. And also x minus 6 is 0, from which we obtain x is equal to negative 6, and here x is equal to positive 6. In isolating x, of course, the constant moves to the other side of the equation, so we have to use the opposite operation. Instead of adding, subtracting, and instead of subtracting, adding. So we end up with both positive and negative 6 as our 2 answers there. Okay, notice that the 2 is ignored in the step where we are finding the roots or the answers. Okay, so we are just taking the factors that involve x and setting them equal to 0. In fact, you don't even need to keep the 2 around here in the front. If you don't like that, you could not show the 2 here in the front. You can just picture dividing 0 by 2 on the right side. And then this wouldn't even be present here at all. Okay, but I've left it in the front. So here's the second example. Again, the very first thing we have to do is ensure that we have the correct form. So we want to ensure that we have right side 0. So we're going to bring these terms over to the left side. And again, it's going to involve subtracting 3x squared and subtracting 21. And so it'll be 7x squared minus 3x squared. Negative 4 is already here, and then we have to subtract 21. collect these like terms now, and we have 4x squared and negative 25. Okay, two terms, subtraction sign in between the two terms. And again, I'm hoping that you'll see that this is difference of squares factoring. The value of a is the square root of 4x squared, so it's 2x. The value of b would be 5. Okay, remember, if you find it helpful, this is optional and not required. You could actually put this step in first before going to the factored form, which would be 2x plus 5, 2x minus 5, like this. Okay, but it's quite acceptable to go from here to here. And then again, we get our two roots by setting each of these factors equal to 0. So 2x plus 5 is 0, and 2x minus 5 is 0. To get our final values for x that would satisfy the original equation, this one here in this case, we isolate x. So first we move the constant. So 2x is negative 5. Then we divide by the coefficient. So x is negative 5 halves. Here, first remove the constant. We will get positive 5. Then we divide by 2 to get our second result. So these answers are positive and negative 5 halves. Okay? Okay, so if it's going to be a factorable quadratic and the middle term is missing, okay, you can see that here. We have a squared term and a constant, a squared term and a constant. If that's the case, the kind of factoring you're going to ultimately use will be difference of squares. Okay, so we might want to indicate that here, that we are using, in this case, difference of squares factoring when we have what we call a pure quadratic. And you're certainly not responsible for knowing that it's called pure. Simply need to know how to do the math to solve. Okay? All right, so let's go and look at a second case. The next case we're gonna look at will have nothing in this position here. So it'll be of the form ax squared plus bx equals 0. This is what we call an incomplete quadratic. And let's see what kind of factoring we will use. All right, so as I just suggested, we're gonna take a look now at what we call an incomplete quadratic. So there is no constant term. There is a term of degree 2 and a term of degree 1, but no constant term. But the same thing applies. We have to start by making one side of the equation equal to 0. All right, so in this case, we could either bring this term to the left side using subtraction, or we can bring this term to the right side using subtraction. Both ways will work, and both ways will give us 0 on one side of the equation. I think I'll just go this way, because I think that's what most students might do, is keep the 0 on the right. But this, of course, would be the same thing as having 21x squared minus 15x equals 0. That would be the exact same thing. But I've done it this way. Okay, what kind of factoring can we use? Well, always consider common factoring first, right? Always. And yes, indeed, we have common factor here. Not only is x present in both terms, both of these terms are divisible by 3. So let's start by removing 3x. Dividing the terms by 3x will give me 5 minus 7x. Okay, Don't forget, you could always open these up using multiplication to check your factoring. Now we take the factors containing x and we set them equal to 0. That means this one here and this one here. Okay, so we are going to write 3x is equal to 0 and 5 minus 7x is equal to 0. And now we isolate x. How do we do that here? We divide by the coefficient of x, which is 3. So x is 0 divided by 3. And that, of course, will remain 0. How would we do that here? We would move the constant first. So negative 7x is equal to negative 5. Currently, this is positive 5 sitting here. So on the other side, we will have negative 5. Now we divide by the coefficient of x. So that means dividing negative 5 by negative 7. When you leave your answer as a fraction, you would never keep both numerator and denominator negative. This fraction is the same as this one, 5 over 7, and this is the correct form of the fraction. Okay, so two answers. Once again, they are 0 and 5/7. Okay, let's try this one. Now, it isn't apparent that this is an incomplete quadratic right now because, in fact, I see a constant right here. But let's start by getting it in the correct form. Remember, that form should be with right side 0 and comparable to ax squared plus bx plus c on the left side. So we have to clean this up quite a lot. Starting with the squaring of a binomial. You may already know what the square of x plus 3 is. But if you're not sure, then you do this. Okay? And following that, you do the multiplication here. Okay, so the first term, the outside, the inside term, and the last term. Okay, using multiplication, multiply, 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 and many students call that foiling, first outside, inside, last. Okay, so then we finally arrive at the correct form for the square of the binomial. When you square this binomial, you get this trinomial. And again, you can go right from this step to this one if you know how to do that directly. So x squared plus 6x plus 9. So now we have to get quadratic form. So right side 0, which means we're going to be subtracting 9 and adding 2x. So x squared plus 6x plus 2x plus 9 minus 9. Okay, so this 9 is subtracted, this 2x is added when they go to the left side. And now what do we end up with here? Collection of like terms, x squared plus 8x. Plus 0, so no constant. And so now you can see clearly that it is an incomplete quadratic because we have the squared term, the term of degree 1, which just means x to the power of 1, and no constant. So how is this handled? Remove the common factor of, in this case, x, only x. Here we were able to take out 3x. Here only x. In here will be x plus 8. Set each factor containing x equal to 0. So x is 0. And also x plus 8 is 0. From which x is equal to negative 8. Okay. When we have an incomplete quadratic, It seems the method that we use for our factoring is just common factoring. Okay, so remember that if it was the pure quadratic, we used difference of squares, and now we just went through the case of the incomplete quadratic and we used common factoring. Okay. Lastly, final case is the complete quadratic. We have all terms present, the squared term, the term of degree 1, and the constant term. So we have to start by making sure we have the correct order of terms. Right side is 0, so we're ready to factor. This is a trinomial, so we're going to use the product and sum method. Now, luckily, this one starts with an easy trinomial. So the leading coefficient is 1, which means we can use our shortcut and go right to this form. How do we end up with the numbers here and here? We look for two numbers with a product of 42. The same two numbers have to have a sum of 13. What are these numbers? 6 and 7. So the factors are x plus 6 and x plus 7. Of course, if you expand this and collect like terms, you'll get this trinomial back. All right, so it's fully factored. Now we come up with the two x value answers. They are -6 and -7. Okay, so this was an easy trinomial because the coefficient of x squared was 1. Okay, let's move on. We're going to do two more examples together. All right, let's take a look at this one. This is not an easy trinomial here. In fact, we've got a leading coefficient of 15. These terms are not divisible by 15, so we're stuck with this tricky trinomial. So we have to do this. We have to take 15 and multiply it by -8 to get -120. The sum we're looking for is -14. So you're quite accustomed to figuring out these numbers now. Sometimes it takes you a couple of minutes. In this case, the two numbers will be -20 and +6. When you multiply these together, you will get this number. When you add these together, you will get this one. So you know the drill by now. We've been factoring for quite a long time. We replace this middle term. Okay, so it'll be a -20x and a +6x. Common factor, the first two terms. So we're using grouping here. What's common to the first two terms? 5x is common there. And to these two terms, just 2. Here's what we needed. This matching binomial, which of course becomes one of the factors. And the other is here, 5x plus 2. So it's perfectly factored. Again, you could do the multiplication here to check your factoring. And now to get our answers, we set each of these equal to 0. Okay, move the constant first, then divide. So 4/3, move the constant, then divide, -2/5. And by now, you might see the pattern. So you can go right from this step to writing down these answers of 4/3 and -2/5. Okay, if you're capable of doing that. So that would allow you to skip this line and this line. But I leave it up to you whether you show those or not. Okay? All right, so last one that we're gonna do together, and this is reminiscent of a previous problem we did today where we had to square a binomial. So let's get started. We square the binomial. Okay, so first, outside, inside, last. So the square of the original binomial is 4x squared minus 12x plus 9. Okay, and again, you can go directly from here to here if you already know how to do that without writing it on paper. Okay, so we've correctly squared the binomial, and as you know, we have to get our quadratic form first. So right side 0, that means we're going to be subtracting 2x and adding x squared, like this. 4x squared plus x squared, negative 12x minus 2x. And our resulting trinomial is then 5x squared minus 14x plus 9 is 0. Okay, so we have a complete quadratic. It is a trinomial. There is no common factor for this trinomial. The leading coefficient is not 1, so this is what we call the tricky or general trinomial. So we factor it like this. We want two numbers whose product is 5 times 9 or 45. The sum of the two numbers has to be negative 14. So what are those numbers? Negative 9, negative 5 are correct here. Okay, they have a product of 45. They have a sum of negative 14. So let's replace our middle term with negative 9x, negative 5x. Remember that any order in the middle here is appropriate. So I could have put negative 5x first, followed by negative 9x. The factoring works either way. In the order that I've chosen, there's only a common factor here of x for that first binomial. And in looking at what's common for this second binomial, it appears as though nothing is common. This is when we have to remember to take out, in this case, a factor of negative 1. Okay, the sign in front of this third term is always the correct sign to remove here, by the way. Okay, but it is in taking out negative 1 using division that we would get a perfect match here. If we only took out positive 1, this would say negative 5x plus 9, and it would then not match here. So negative 1 is the perfect choice to give us the matching binomial, which of course then is our first factor. And the other one is here, x minus 1. Like this, so that's perfectly factored. If you were to expand it out using multiplication, of course, you should get this line back. Okay, so come up with the two answers by taking those factors containing x and setting them equal to 0. Move that constant, divide by the coefficient of x here, just move the constant. So our answers are 9/5 and 1. And in terms of answers in general, You're welcome to use decimals instead. Just make sure you don't do any rounding. So don't use a decimal if it means you're going to have to round your answer. Okay, you should only be rounding if you are explicitly instructed to do so. But in this example, for one, of course, is the answer here. And here, this is the same as 1 4/5, if you like the mixed fraction. It's also the same as 1.8 if you want to express it as a decimal. Same thing here. This is negative 0.4 if you'd prefer to use a decimal. And this is what I mean. Here you would not, okay, so let's just write down or negative 0.4 would be fine here. You would not round this. So this is the same as 1 1/3 if you want a mixed fraction. As a decimal, it's 1.3 repeated. Okay, so don't forget to show that the digit of 3 is repeated, because this is not 1.3, it's 1.33333 forever and ever and ever. Okay? Okay, so that last case, the case of a complete quadratic, we didn't use difference of squares, we didn't use common factoring, but what we did do is factor the trinomial. Okay, so that's our summary. There are 3 main categories for the lesson today. If this middle term is missing, you'll be using difference of squares, ultimately, perhaps after common factoring. If the last constant term is missing, you'll be using common factoring only. And if you have all 3 terms present for the quadratic, you'll be factoring a trinomial. Now, perhaps it's an easy trinomial, or perhaps it's a tricky trinomial. Okay? Okay, so this is the first method of solving quadratics. The next video will show how to solve quadratics by using completion of the square. You should definitely practice this material here. Check Blackboard, because I've posted there the recommended problems from your textbook. Okay? All right. Thanks very much for watching the video. If you have any questions, don't forget you can send me an email message. Have a great day.